Good morning, Math 2 students. Today we're going to be dealing with our exponents again. We're going to do a lot of practice with exponents. So right here, that top part where it talks about, okay, these are the rules of your exponents that you have to practice and understand and know the difference. We've been doing some. You guys have been doing pretty good, but I want to make sure that you have it. And then I'm going to practice a couple, and then you'll work the rest of this sheet out. Okay, so there's 30 problems plus the 5 up here examples. So there's 35 altogether. I'll do the top 5 for sure. Then I'll pick and choose a few in the middle, and then you do the rest and submit it. Okay. So again, this is for April 13th, Monday. Hope you're having fun. There'll be some Zoom meetings this week. One Zoom meeting for you this week, and I'll have information out on that soon. So the product rule. The product rule deals with, make it bigger, when you have a variable that have the exact same base. Now remember, if I have x, if I have x to the third power, this is the base. The 3 is the exponent. Not too hard to understand, but when you have the like bases, the same base, what they're saying is that x to the 5th is really x times x times x times x times x. Remember, it's something multiplied by itself, the exponent a number of times, so 5 times. X to the 3rd is x times x times x. And those two are being multiplied, so that's one big multiplication. So now I can put it together in one big x to the 1, 2, 3, 4, 5, 6, 7, 8th power. So really when you have like bases, okay, like we do here, what you do is you take x to the 5th, x to the 3rd, and we take x and we add the exponents. 5 plus 3, which gets us at x to the 8th. It's the same thing. So the product, multiplication, is add exponents. So quotient, which is division or a fraction bar, is the opposite. Remember, multiplication and division are opposites. So if in multiplication you add them, in division or quotient you're going to subtract. But how do we understand it? X to the 5th is x times x times x times x times x. X to the 3rd on bottom is x times x times x. And remember, with fractions you can cancel. If there's one x on top, cancel the one on bottom, one on top, one on bottom, one on top, one on bottom. That leaves just these two, or x squared on top. Or if you remember, take the 5 minus the 3, and then if the largest exponent is on top, that x stays on top. If the largest exponent was on bottom, then the x would stay on bottom or in the denominator. Whenever you have x squared or anything on top with only 1 or nothing on bottom, it just stays x squared. Okay? Then we have the power rule, where we're taking a power, x to the 5th, raised to a power. What this means is x to the 5th, oops, sorry about that. Let's do it again. X to the 5th times x to the 5th times x to the 5th. And if you remember what we just did over here with multiplication, whenever you have like bases and you're multiplying, we can write it all out, or we just add the exponents. So this becomes 5 plus 5 plus 5, or x to the 15th power. Or the power rule says, if you take an exponent and you raise it to a power, we just multiply those two, x to the 15th power. And the same thing we have here, okay? The other two ideas is when you have a negative exponent, we can never have negatives. So to make an exponent from negative to positive, we just move it to, we look at it as a fraction. If it's on top, we move it down, okay? If it was a fraction and it was on bottom, we'd move it up, okay? If there is no denominator, we just assume it to be 1, then we'll flip it, 1 over x to the positive 5th. That's how we get rid of that negative, okay? That's pretty simple. And last but not least, Anything to the 0 power is 1. If you're not sure, take your calculator, take 5 to the 0 power, you'll get 1. Take 100 to the 0 power, you get 1. And the reason why that works is this. Okay, let me explain it to you this way. If you have 5 to the second power, that means 5 times 5. But what they're not saying is, let's go down. What's 5 to the first power? Well, that's just 5. So 5 to the 0 power, I'm trying to teach you that it's 1. Well, anything times 1 is itself. So what they're really saying is 5 to the second power is really 1 times 5 times 5. So here's where it's used twice, and this is what's left. Okay? 5 to the third power is 1 times 5 times 5 times 5. 5 to the first power is 1 times 5, and then 5 to the 0 power is 5. So there's those 3 for 5 to the third. There's those 2 for 5 squared. There's the one of them for 5. Ooh, I'm sorry. That's 1 times 5, and then this is 1. So here's the 1 when there's 5 to the first power, just one of them, and then that's what you get anytime you put something to the 0 power. Use your calculator, you'll be able to see it. It's not too hard. So what they want you to do is simplify a few of these. So really, like on number 1, there's nothing to do with the y's, so that's going to stay. This is all over 1, and we got to get rid of that negative exponent, so we're going to move it down. So this becomes y to the third over x to the 7th. Since they're different bases, we can't add or subtract those exponents. We leave it alone. Okay, here, over 1. So the 9 comes down, but b to the 0 power becomes 1. So this becomes 1, because this goes up, times b to the 0 power, which is 1, over a to the 9th. Okay, and that's just 1 over a to the 9th power. Pretty simple. Okay. When we do number 6, we have like bases, and we're multiplying, so we add the exponents. X to the 11th power. You're done. You can take this to x times x times x. You can take this to x times 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 x. I think that's 1, 2, 3, 4, 5, right? And then 1, 2, 3, that's 8 of them. 1, 2, 3, that's 11 of them. If I multiply this all together, that's x to the 11th. Okay? So, what's this? It's 9 plus 4 is 13. 13 plus 2 is 15. A to the 15th power. Now, they're trying to trick you on number 8. Really, you have a k, a k, a k. You can add straight across. Even though you would think move this one to the bottom, first off, whenever you see all the same variables, add straight across. Add those exponents. 3, negative 4, 7. So 3 plus negative 4 is negative 1. Negative 1 plus 7 is 6. So this becomes k to the 6th power. You could have taken k to the 3rd times k to the 7th over k to the 4th by moving that down. And then this would become k, this becomes k to the 10th over k to the 4th. And then if you remember our division rules, 4 minus 6 becomes k to the 6th. 10 minus 4 becomes k to the 6th. Okay? So it all works the same. So we have some here. All right, let's look at number 14. We have m, common base, m. We have 11 and 5. We take 11 minus 5 is 6. The largest exponent was on top, so it says m to the 6th on top over 1 or m to the 6th. You're done. Okay. 16, raising powers to powers. Now they're going to try to trick you a little bit because we just did x to the 3rd times x to the 8th, got x to the, I'm sorry about this, x to the 11th. I don't know what I'm doing. There we go. So we got when we just did, x to the third times x to the 8th, that's x to the 11th. But here, it's not x to the third times x to the 8th. It's x to the third raised to the 8th. It really means you have x to the third times 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 x to the third. We have 1, 2, 3, 4, 5, 6, 7, 8 of them. So now we can add all the 3's. So if we do add the 3's, 3, 6, 9, 12, 15, 18, 21, 24. X to the 24th power, or 3 times 8 is 24. Okay? So a to the 9th raised to the 4th power. 9 times 4 is a to the 36th power. Okay? Then they're going to put it all together like in number 26. So you're going to look at this first, and then you're going to look at this second. So the first part is raised to the 4th power. So that means this gets multiplied there, this gets multiplied there. So that a to the 7th. 7 times 4 is a to the 28th. B to the 3rd, raised to the 4th. 3 times 4 is b to the 12th. There's no exponent here, so these just stay the same. A to the 8th and b to the 2nd. Now we multiply those because it's all multiplication in between. A to the 28th times a to the 8th is a to the 36th power. B to the 12th times b squared. 12 plus 2 is b to the 14th power. And there's your answer. Okay? That's all you're doing. That's all you do. Okay? I want you practicing these. I don't have a key. I want to take a look at your work. All right? So when you're done with